Welcome to our program, Astronomy for Everyone. For this evening's program, we're going to talk about the Cassini mission to Saturn. With me here in the studio is Steve Whitty, a member of the Ford Club. Steve, welcome to the program.
Great to be here.
Now, we're going to talk about the Cassini mission. Anything in particular about this mission?
Well, I gave this talk about a year ago. The Cassini mission the Cassini orbiter has been orbiting Saturn for a number of years, since 2004. So it's been orbiting now for about 7 years, and it took about 7 years to get to Saturn from Earth. So it was launched in 1997. So I gave this talk about a year ago at the Warren Club at one of their regular meetings, but that was an hour-long talk, and this is a half-hour show. So we're going to just talk about Titan. Titan is a very interesting moon. It's the only moon in the solar system, the only moon of any planet in the solar system that has its own atmosphere. And the atmosphere is very interesting on top of that because, like Earth, it's a mostly nitrogen atmosphere. Now, there's no oxygen like there is on Earth. That's because life generates oxygen, mostly plants, on Earth. What Titan has instead is methane and ethane in the atmosphere, and that's kind of interesting as well.
Because it's so cold there on Titan, obviously there's no photosynthesis as we know it here.
That's right. Saturn, and therefore Titan, is about 10 times as far away from the sun as the Earth is, and so it gets about 1/100th of the energy, the heat energy, that the Earth gets. So it's very cold.
We're looking at the range of about minus 300 degrees Fahrenheit?
Something like that, yeah. Minus 270, for example, is a good number. And it's a critical number, as it turns out. We'll get to it later. But it's a critical number because you would think that water would be frozen solid. In fact, planetary scientists, thinking about Titan, think of water as basically rock because it's so hard.
At those temperatures?
At those temperatures.
Now, you mentioned Cassini. Was Cassini the first mission to view Titan?
No. Pioneer 11 did a flyby of Saturn, and Voyagers 1 and 2 also did flybys of Saturn. Voyager 2 actually went by Saturn before Voyager 1 did. They were basically the same craft, and since Voyager 2 was so successful at investigating Saturn, they diverted Titan to, they diverted Voyager 2, I'm sorry, they diverted Voyager 1 to Titan to do a close-up investigation. That meant that Voyager 1 could not go on to see Uranus and Neptune, but Voyager 2 went ahead and did that, so we've got that data.
Okay.
It was a little bit of a disappointment because Voyager 1, when it used its cameras to look at Titan, it couldn't see the surface. The atmosphere is like a smog. It's very opaque. It's very thick. So you couldn't see the surface at all. So it did do some interesting measurements, but it didn't get us what we really wanted to know. We wanted to know what it was like on Titan.
So when we sent Cassini, we sent different type of cameras?
Absolutely. We sent a whole bunch of instruments. I think of Cassini, the mission, the spacecraft, as basically being a school bus. It's huge, and it's got tons and tons of instruments. Two of them that are really important, though, for looking at the surface of Titan are a special infrared camera. There's a small wavelength, small wave band, if you will, where you can actually see all the way down to the surface of Titan in infrared. And also, Cassini carries radar, so it sends radio waves to Titan, and then they bounce off and they come back, and Cassini can make a radar map in swaths, not the whole planet, but in swaths with high resolution, and they can get data from the surface.
Now, in addition to studying Titan from orbit with Cassini, wasn't there also a lander with that program?
That's right. That's right. Cassini carried a European mission, in fact, the Huygens lander. And the Huygens lander, it had its own little batteries. And the probe was dropped into the Titan atmosphere. The parachutes opened, and it made a soft landing on Titan. Now, since Voyager 1 didn't actually get to image the surface, people were wondering what they would see when they got there. And it might have been an ocean. A lot of people thought that this methane and ethane in the atmosphere would rain and create a big ocean, perhaps even a planet-wide ocean. And so they thought, well, we've got to be prepared for that. And the Huygens lander was prepared to land in a liquid or a solid. And so when it made it down to the ground, it turned out that it landed on a solid. It had the consistency of a sort of a fairly hard slush. But it was basically dry.
Okay.
And it looked like a lake bed. And in fact, as the Huygens lander was coming down to the ground, you can actually see in the images, you can see what looks like little river channels that cut into the edge of a dried lake. And so you have dried river channels into a dried lake, and Huygens lands in the middle of that.
Okay, so it's landed on a solid surface, but we have found that there are lakes on Titan.
That's right. With radar measurements, it turns out that so the radar isn't. You see images, but it's really data. The radar images tell you different things, though, than you get visually. What it really tells you is the texture of the surface that you've imaged, and it's very conspicuous in the data. You have these very, very smooth sections, and so the assumption is that they were lakes. But you would really like some sort of alternate data that confirms your suspicion, and it turns out that we got it.
Oh, okay.
So we had to wait for the geometry to change. We had to wait. So Saturn has an axial tilt like the Earth does, and so it has seasons like the Earth does. But since it takes 30 years to go around, it takes 30 years to go from winter to summer to winter, if you were like in the Northern Hemisphere.
Sure.
And so we had to wait until we went from illumination of the south to illumination of the north. And then on top of that, the Cassini spacecraft had to be in the right position, and they caught what's called a glint off of one of the lakes.
Much like a glint off of a lake here on Earth, right?
That's right. If you fly in an airplane over a lake and you look down by your shadow, you can often see a lot of light, a bright light, shining directly off the lake right back at you, right around the shadow.
Now, we were talking about some extremely cold temperatures, so glint off of liquid is not water. What is the liquid?
That's right. So the liquid is methane and ethane. It's a combination of these two hydrocarbons. Methane is a gas on Earth, but at these cold temperatures, it's often a liquid. And in fact, there are clouds of methane-ethane clouds that have been detected on Titan, and in fact, rain has been detected on Titan.
A methane rain.
That's right. Methane,
not unlike the water rain we have here on Earth.
And so those river channels that were cut, that Huygens saw, were probably cut by some methane-ethane combination, and it probably filled that lake bed that Huygens landed on at one point. Now the lakes that we see are either in the southern hemisphere or the northern hemisphere, and Huygens landed at the near the equator. So at the moment, we think of the equator as being basically a huge desert, if you will, cold desert, and the northern and southern hemispheres have these lakes. In the beginning of the beginning of the Cassini mission, the first 7-something years, we were in the southern hemisphere of Titan and Saturn were illuminated by the sun, and over the years, successive images, as Cassini passes Titan, successive images have shown the same lake getting smaller in the southern hemisphere. And
during their summer.
During that summer. Mm-hmm. And during that same time, the lakes in the northern hemisphere got larger. So presumably you had evaporation in the south, the clouds carry the methane up to the north, and it rains in the north, and the lakes there are getting bigger. The glint that was discovered earlier was this very large lake, which they call Kraken. It was discovered in radar data and then confirmed with this glint in infrared data. And this lake is utterly huge. It's 150,000 square miles. Now, this is a number that I couldn't really wrap my head around, so I said, well, what if it was a circle? It's not. What if it was exactly round? How big would it be? Well, it would be 400 miles across. You know, so that's like Detroit to Pittsburgh, maybe? It's quite a big area.
That's huge. That's huge.
So it's not just a Great Lake, it's just humongous.
Now, on Titan, it has a crust or a mantle, and with, I'm assuming, water ice and other ices. What else can we find on the inside of Titan?
Yeah, so Cassini, being in orbit of Saturn and making multiple passes at Titan, they can do something called gravity maps. And basically all they do is when they fly by, they're also sending radio back to Earth. And Earth radios pick that up, and you can very precisely figure out where the spacecraft is going. And as it goes by Titan, the various gravity differences from within the body, the object, deflect the orbiter a little bit. And so they have gravity maps of Titan. And from these gravity maps, you can actually figure out the structure. And the structure that we now understand has changed. We used to think that there was a rocky core, followed by an icy layer, followed by perhaps some sort of an ocean, and then a crust. That's the picture on the left in the image that's up. But from the Cassini data, it's quite clear that the rock and ice never fully separated. The rock would be heavier and fall to the center, but for whatever reason, the rock and ice never did fully separate, and you have
sort of an intermediate zone of rock and ice together?
That's right. You have a mixture of rock and ice. And then you still have an ocean layer, which we'll get back to, and then a crust, which is then the top of the crust is then the surface.
Do we see similar things in some of the other moons of our solar system?
Yeah, that's right. Two of the big moons of Jupiter, Ganymede and Callisto, have similar structures. And it's kind of interesting, and all three moons are very similar in size. Ganymede is the biggest, Titan is the second largest, Callisto is the smallest of the three. Well, Ganymede is just a little bit bigger, and it's a little bit further out from Jupiter than Callisto is. And so its inner core has been able to differentiate into rock as a separate entity, and then an ice layer, and then an ocean. Callisto, like Titan, has this mixed rock and ice. So it has to do with, for orbiting Jupiter, it has to do with how far from Jupiter they orbit and the interactions with the other moons.
So then the similar would hold true then for Titan, to a degree?
To a degree, we expect that, but there may be something more complicated going on with Titan. And if we have time, we'll get to that. It's kind of a funny story, and it's really exciting.
Now, it sounds like in the case of Titan and maybe even Callisto and Ganymede, that the mantles and that are not cemented, if you will, to their cores. Is there some slippage going on here?
Okay, so on Titan, we have the best data. The Galileo orbiter orbited Jupiter and studied those moons, but Cassini has been at Saturn longer and has had more time to play with it. Each time, or almost each time, that the Cassini orbiter passes Titan, it does a radar swath. And you know, a few weeks later, there'll be another pass, and there's another radar swath. And after a while, you get radar swaths that overlap. Now, you'd like to line up these radar swaths where they overlap and see if anything changed, or, you know, but you really want to line them up. And it turns out that if you've got 3 of these things, you can line up 2 of them. But when you line up the third one, maybe it lines up on one side but not the other. They don't, in fact, line up. And that's because the crust of Titan has shifted a little bit, as much as 30 miles. So the crust of Titan is not coupled to the core of Titan, and it gets blown around by the wind. Now, for Ganymede and Callisto, this may also be true, but Galileo wasn't able to detect it. And partly that would be because there's no wind, there's no air, and therefore no wind on either Ganymede or Callisto.
This is fascinating, Steve. In the couple of minutes we have remaining, is there anything else interesting you'd like to tell our audience?
Okay, so the origin of Titan is kind of interesting.
Okay.
There's some controversy that goes on with it. There's a researcher, Dr. Prentice, who has a theory for the formation of the whole solar system, not just the Saturn system. And it makes very specific predictions. And these models that he has have made a lot of predictions that when spacecraft like the Voyagers have gone out there, they turn out to be correct. The data actually supports them. But they're still controversial in many ways. So this is sort of speculative science. And one of the predictions that this theory makes is that Titan did not, in fact, form at the same time as Saturn did. That it's a planet, that it was its own free planet at one point, and then was captured by Saturn. One way that could have happened is if Titan was either at the Sun, Saturn, Titan L4 or L5 Lagrangian point, and it got big enough to be destabilized, and then got captured by Saturn. But it would have messed up all of the moons of Saturn. One of the pieces of evidence against this idea is that Titan's orbit is really quite circular. But it's very interesting that could have happened.
It is. Steve, this has been an interesting conversation. If any of you out there have any questions that you'd like to forward to us about Titan, or really about anything else, please visit our website. You can see the address there at the bottom of your screen. And don't go away. We'll be right back.
We wanted to spend a moment to talk about an important anniversary. 50 years ago, the Russians successfully launched the first human in space, Yuri Gagarin. Followed just about a month later, this month, on May the 5th, Alan Shepard became the first American to go into outer space on the spacecraft called Freedom 7. Now, Alan's flight was not in orbit like Yuri Gagarin's. It was a suborbital flight, lifting off from Cape Canaveral into the Atlantic Ocean. He later on commanded Apollo 14, which went to the Fra Mauro Highlands. Now, he also made himself endeared to golf fans around the world when he produced a golf club head, attached it to one of the tools supplied for bringing back samples from the moon, and used it to make 3 golf shots, more like chip shots, off the surface of the moon. So 50 years ago, America entered the manned space race with the Soviet Union. We also want to thank you for writing your emails to us, and those are being replied by email. So if you'd like to ask a question of any of the staff here at Astronomy for Everyone, please send your emails to the address which will appear at the bottom of our screen. Thank you very much, and back to Steve Whitty for Astronomical Term of the Month.
Thanks, John. The term of the month for the month of May 2011 is syzygy. It's a great term because it has, well, it either has no vowels or it sometimes has a vowel. Anyway, syzygy is a simple term, and it means, in astronomy, it means 3 or more astronomical objects that are aligned, that are aligned in a straight line. So when you have a full moon, then you have the Earth, well, you have the Sun, the Earth, and then the Moon in a line. Or at a new moon, you have the Sun, the Moon, and the Earth in a line. If, like in April, we had the closest approach of Saturn, it's not terribly close, and you had the Sun, the Earth, and then Saturn in a straight line. So this is when Saturn is as close to the Earth as it gets. Now Saturn is about 10 times as far from the Sun as the Earth is. And one of the interesting questions is, well, how long does it take data from the Cassini mission, which is orbiting Saturn, how long does it take that data to get back to Earth? Well, light travels pretty fast, but not instantaneously, not infinitely fast. And it takes about 8 minutes and 20 seconds for light to get from the Sun to the Earth. Saturn being 10 times as far, it takes about 80 minutes to get from the Sun to Saturn. Well, when we have syzygy between the Sun, the Earth, and Saturn, you subtract the 8 minutes and get something like 72 minutes from the Earth to Saturn, to Cassini at Saturn, and then 72 minutes from Saturn and Cassini back to the Earth. So there's quite a round trip time. But when the Earth is on the other side of the Sun from Saturn, you have to add the 8 minutes. So it's more like 90 minutes from the Earth to Saturn, and then from Saturn back to the Earth. Well, back in March, there was a prediction that we were going to have a supermoon on the 19th of March. And a supermoon was predicted, a supermoon is defined loosely as when the moon is as close to the Earth as it gets, because it's got an elliptical orbit. Sometimes it's a little farther out, sometimes it's a little closer in. So when the moon happens to be at full moon, and it happens to be as close to the Earth as possible, then you have this supermoon. And there was a prediction that there would be earthquakes at that time. And you may have remembered that there was an earthquake in March. I'll get to that in a second. Oddly enough, there is no real correlation in the data of earthquakes over 100 years between full moon or new moon and earthquakes. You might expect some, but there isn't any real correlation. So new moon and full moon, and certainly not supermoons, are not predictive of earthquakes. Now, we did have an earthquake in March in Japan, and it was a very large one. But it didn't happen at the full moon. It happened at first quarter. Now, this is where the moon is at a 90-degree angle between the line, with the line of the Earth to the Sun. So 90-degree angle, this is actually the weakest gravity that the Earth and the Moon have. So the Japan earthquake had nothing to do with the supermoon, which had not in fact happened yet. Just absolutely nothing to do with it. And the new moon that preceded it, that would have been at apogee, that would have been as far from the Earth as possible. So that would have been a weaker new moon than usual. So don't believe everything you hear. The term of the month is syzygy. Now back to you, John, for What's Up.
Welcome to What's Up in the Nighttime Sky. I'm John Schroer. In May, the moon will start as a new moon, which means it won't be visible from here on the Earth, and that's going to happen on May the 3rd. This is when the side of the moon that always faces Earth is receiving no sunlight, therefore it can't be seen. Approximately 7 days later, we have the first quarter moon. Now this is a favorite time for amateur astronomers because they love to look at the line between day and night called the terminator. You can see craters being divided into day and night, and some of the craters will have central peaks, mountains that formed when the object crashed into the moon, and you can see the crater in darkness, but the central peak, the mountain in the middle of the crater, will be in daylight. It will see the first light of dawn. The full moon will be on May the 17th, and we're going to conclude with the third quarter moon, which means it won't be visible until early morning, and that'll be on May the 24th. Now, most astronomers and most people think that astronomers do most of the observing in the dead of night. May is going to give you a real treat if you don't mind getting up sort of early in the morning. Now by May, the sun is rising by about 6 o'clock to 6:30 in the morning. If you get up around 5:30 and look to the east by southeastern sky, you're not going to see 1 or 2 or even 3 planets. You're going to see 4 planets. Mercury, Venus, Mars, and Jupiter will all be in the early morning twilight before the sun rises. Now, Mercury is usually the hardest to see because it's only 36 million miles away from the sun. This point, it is furthest in the western elongation from the sun. It's furthest away from the sun than it can be, and this is on around the 13th of May. It's a great time to look at it. Now, above Mercury, you will see Jupiter and Mars, and the brightest one of all, Venus. Now, Venus is brightest because of it's surrounded by clouds, being closer to the sun than the Earth is, and it's actually the closest one to the Earth. All that makes for a lot of reflectivity, making Venus actually the 4th brightest light in our skies. The first is the sun, the second the full moon, the third the International Space Station, and then Venus. Now, you're probably wondering the other planet that we can see in the evening sky, and that's Saturn. Now, Saturn will make an appearance until the evening sky, and here you'll find it in the south by southwestern sky. On the 13th, the same day that you can see the planets early in the morning, you will see the waxing or gibbous moon. So you will, if you can't find Saturn by yourself, look for the moon on the 13th and look above it and to the left, and that bright light you see will be Saturn. Now, in the old days, Saturn was thought to have just a few moons. Today, that number stands at 60. Only Jupiter has more, with a current count of 63 moons. If you're interested in learning more about the night sky or how to find the planets, there are lots of websites that you can go to, including astronomyforeveryone.com. That concludes What's Up with the Night Sky for May 2011.